Hello everyone and welcome back. I am Matias and I'll be your host for this episode. This is how to make a Metroidvania Part 7, where we'll be teaching you how you can create a Metroidvania like Hollow Knight in Unity. In this episode, we'll be creating a death and respawning system, updating map UI, and saving system. These mechanics are crucial for creating interesting and engaging gameplay for the player. Alright, before we cover this episode's content, we'll fix a bug from the last episode. So we've got a bug that causes a null reference exception error. This is because this is calling for a collider with the enemy tag. But if there is no collision, there won't be an enemy collider, so it throws the error. So we'll just remove this line of code. Now to make them flip when they collide with other enemies, we'll just add an onTrigger enter. If it collides with an enemy tag, we'll just call the flip state. Now as there's no flip state for the charger, we'll just flip it manually. Okay, now let's test it out. Excellent! Alright, now we can move on. So right now, we have a health system, but if we lose all our HP, we don't actually die. So let's add a dying mechanic. Okay, firstly, let's create the death animation. I'll be fading out the sprite after the death to make it look nicer. Okay, then uncheck loop time. We'll link it from any state. Then we'll create a trigger called death and add it to the arrow. Now, as we're not disabling or destroying the player game object, we'll create a bool alive in the player state list to tell all the other functions if the player is alive or not. We'll create a coroutine to handle the death function. So firstly, we'll set the alive bool to false. Then, timescale to 1, as we don't want the hit stop time to cause any problems. Then we'll instantiate the blood particles and finally call the death animation. Now, we'll wait for seconds before doing some UI shenanigans. Back in the editor, let's create a death screen. We'll be using the scene fader object as well, so we just need a text that says you died. And a respawn prompt. Now in the UI manager, we'll create a serialized game object, death screen. Then we'll create a coroutine, activate death screen. So let's wait a moment before activating the fader to let the fact that the player died sink in. Wait a moment until the fader is fully black before activating the death screen. Now, we'll call the activate death screen in the player controller. Let's call the activate death screen after the wait for seconds in the death function. Finally, we'll call the death function in the take damage, but only if the health is less than or equal to 0. Else, we'll just call the stop taking damage coroutine. Right, before I forget, let's restrict the player to only be able to do its action functions when it's alive. Let's also make the enemy stop aggroing when the player is not alive. We'll also only call the hit stop time function when the player is alive. Otherwise, it would mess up the entire death function. Okay, let's assign the death screen and test it out. Let's also decrease the health to 5 so we don't have to wait so long before we die. Perfect, it works. So we have a death function. Now, let's make a respawn function. In Hollow Knight, the player sets their respawn position by interacting with a bench. So let's head over to the input manager and change this submit button to interact. I'll be using the F key for this. Next, we'll create a bench. I'll be using this bench sprite. Link is in the description below. Set the sprite to clamp, point no filter, and drag it into the scene. We'll resize it so it looks appropriate in comparison to the player. Then, we'll add a trigger collider and create a script, bench. In the bench script, we'll create a bool interacted, and then we'll create an onTrigger stay. If the player is inside the trigger collider and interacts with it, set interacted to true. Okay, to handle the respawning, in the game manager, we'll add a public vector2 respawn point to handle the respawn position and a reference to the bench in the scene. Then, create a function respawn player. If the player has interacted with the bench, we'll set the respawn point to the bench's location. Otherwise, we'll just use the platforming respawn point for now. Then after setting the respawn point, we'll set the player's position to the respawn point. And then we'll do some UI shenanigans. So back in the UI manager, we'll create a coroutine, deactivate death screen. And here, we'll set the death screen to false and the screen fader to fade out after a moment. Next up, we'll create a function, respond, in the player controller to handle what happens after they respawn. Firstly, we'll check if the player is still dead, as we only want to call this once. We'll set pstate.alive to true, health to max health, and then we'll force play the idle animation as there's no link to the idle animation from the death animation. We'll call these two functions in respawn player in the same order. We'll assign the respawn player function to the respawn button. Now let's test it out. Works like a charm. In Hollow Knight, the player respawns with a cap on their mana until they kill their shade. So let's also do that. I'll be using the semicircle sprite to show the cap. Link is in the description below. We'll set the sprite to clamp point no filter. Now, we'll make some edits to the canvas prefab. Firstly, we'll create an empty game object, mana stuff, to hold the mana. We'll anchor it to the top left. Then, we'll move the current mana container and fill into it. Afterwards, we'll create a UI image and set it to the semicircle. Set it to preserve aspect and adjust it so that it fits the size of the full mana container. I'll be extending the top of the semicircle to clearly show the cap. Now, in the UI manager, we'll create a serialized game object, half mana and full mana. Next, we'll create an enum mana state with full mana and half mana states. We'll also create a mana state variable so we can access it in other scripts. Now, we'll create a public function, switch mana, with a mana state argument. Here, we'll switch the mana state. So in the full mana state, we want the full mana to show and the half mana to be hidden. Likewise, in the half mana state, we'll set the full mana to false and half mana to true. And finally, set the mana state variable to the mana state arguments variable. This updates the mana state variable accordingly. Okay, now we need to call the switch mana function. So in the player controller, we'll create a bool half mana. Now in the response function, we'll set half mana to true after alive is set to false. And then we'll call the switch mana function. We'll set the mana to 0 as well. Now in the mana property, we'll shift the current code to only run when half mana is false. And if it is true, we'll clamp the mana to half, 0.5. Back in the editor, let's assign the half mana and full mana containers. Now if we test it out, we can see that once we respawn, we'll have a mana cap of half. And the mana fill can only fill to half. Excellent! Okay, now we'll be creating the shade. In Hollow Knight, the shade responds at the location of the knight's death and has to be killed to restore the soul meter. The shade we'll be using will be a version of the knight, So let's drag in the night sprite into the scene. I'll make this sprite completely black and attach a box collider and rigid body to it. Now let's create a script for the shade. We'll be making it a part of the enemy script instead of a mono behavior. I'll be basing the shade script off of the bat script since the shade can fly in Hollow Knight anyway. So we'll copy paste the entire bat script over, but change the names from bat to shade. We'll also need to create states for the shade over in the enemy script. We'll need to create a static instance of the shade as we are only going to have one shade at most. In Awake, we'll make sure there's only one instance of the shade, just like the player. In the change current animation function, we'll comment out most of the code, but keep the death state code. Here, we'll just destroy the game object for now. We'll have to create a function in the player controller to restore the mana, so let's do that now. Let's name the function restore mana and set half mana to false. Then, we'll call the switch mana function in the UI manager. We'll call this restore mana function just before the shade is destroyed. Also, when the player dies, we'll want to instantiate the shade. I'll make a reference to the shade in the game manager. Then when the player death function is called, we'll instantiate the shade a little time after the UI manager.death screen is called. Now if we play, we should be restoring our mana after we kill the shade. I'll write a line of code to kill the player when we press the L key for testing purposes. Alright, let's see if it works. Splendid! Okay, now let's add in the animations for the shade. Firstly, attach an animator to the shade and set its controller to the player's animator. Set it to unscaled time so that the hit stop time won't affect how it looks. In the change current animation function, we'll force play the idle animation when the shade is idle, and set the walking bool to true when the shade is chasing. When the shade dies, we'll play the death animation and destroy it after half a second. Next up, we'll create an override void attack player to play the attack animation and deal damage. Test it out. Amazing! Alright, let's move on to the map system. Needless to say, without a map, navigating through the amazing world of Hollow Knight will be an absolute nightmare. In the canvas prefab, we'll create a UI image map handler. We'll stretch the image and then set the image color to black and decrease its alpha a bit. We'll create an empty game object, maps, to handle the maps. Under it, we'll create another empty game object, cave_1. This will be the map of cave 1. We'll be doing the same for caves 2 and 3 as well. Under the cave 1 game object, we'll create a version of the map using UI images. If you're worried about getting the scale wrong, just take a screenshot of the map in the editor and use that as a template. So that's cave 1 done. That's cave 2. And finally, cave 3. If you have more scenes, you can just repeat the process, but since I only have 3, I'll just be doing these 3. We'll set the map handler to false by default. In the UI manager, we'll create a public reference to the map handler. Then in the player controller, we'll create a bool, open map, and a function, toggle map. If open map is true, UI manager.maphandler.setActive true, else setActive false. In get inputs, we'll define open map to be holding down the map button. We'll set the map button to the M key in the input manager. And finally, we'll call toggle map in updates if the player is alive. Now let's test it out. Awesome! In Hollow Knight, the map starts out limited in its content, but as the knight explores more and more, the map will update and show the locations accordingly. However, the map only updates when the player is benched. We'll create a script, map manager, in the map handler. Firstly, we'll create a GameObject array, maps, to handle the maps for the caves. Then, we'll create a reference for the bench. We'll leave it like that for now, as we'll need to create the save system to do the rest. So for the save system, we'll be using player pref. So for the save system, we'll be using a binary writer. Binary writers are one of the ways you can do a save system in Unity. Player prefs shouldn't be used unless they're saving settings, hence player prefs, as in preferences. We'll create a script called saveData. In this script, we'll be using systems.collections.generic, scene management, and system.io in the namespace. We'll change this from a mono behavior to a struct. This is so that we don't need it present in the scene for it to work. We'll also make this system serializable so that we can store data and load it later. We'll make a public static instance of the saved data. Now how we'll do this is every time the player enters a scene, the name of the scene will be saved into the save system. We'll be using a hash set for this instead of a list, as hash sets can't have repeated values. So we don't have to ensure that the name of the scene is different before it saves. We'll create a function, initialize, to start everything. Firstly, we'll check if the scene names is null, and we'll create a new hash set if it is. In the game manager, we'll create a function, saveScene. Here we'll get the current scene's name and add it to the scene names hash set. And in awake, we'll call saveData.instance.initialize and saveScene. In the map manager, we'll create a function, updateMap, and call the saveData.instance.sceneNames. And if the saved scenes contain the maps, we'll set it active to true, else set it to false. Now if you're doing it my way, you must make sure that the array order is chronological, otherwise it'll cause bugs. Anyway, in the map manager, we'll check if there's a bench in the scene when it's enabled. And if the player has interacted with the bench, we'll update the map. Now let's test it out. I'll move to the next scene and move back to the bench. Interact with it. Perfect. Okay, so now let's expand on the save system. Firstly, I want to save the bench that the player has interacted with so they respond at the bench regardless of which scene they die in. We'll first set the interacted bool to false when the player exits the bench trigger, as now it will only serve to update the map. Next up, we'll move to the saveData script and add a variable string, bench scene name, and vector2 bench pos. We'll create a function, saveBench, and write in a new file, safe.bench.data. The reason why we do this is because the reader reads in an order of what's safe. So if we have one file for each saved item, it'll minimize the risk of accidentally reading another item's data. We'll write the bench scene name, benchpos.x and benchpos.y. Then in the bench script, when the player interacts with the bench, we'll set the bench scene name as the current scene and set the benchpos values as the bench's transform.position. And of course, we'll call the saveBench function. In the game manager, we'll set the respawn point to the benchpos if it exists. Else, just set it to the platforming respawn point for now. Then, if there is a bench scene name saved, load that scene. In order for this to work, when the player exits the play mode as well, we'll have to create a function that loads the bench data. In this loadBench function, we'll use the binary reader to read all the values that we saved. And we'll call it the moment we call the respawn player. Now if we interact with the bench and die in a scene without it, we'll respawn back at the bench. Excellent! Okay, with the saveBench function done, let's make a function to save the player data so that if the player leaves the game, their progress will be saved. We'll create the variables int player health, float player mana, bool player half mana, vector2 player position, string last scene. Then we'll create a function, save player data, and write in a save.player.data file all the previously mentioned variables. And then we'll create another function, loadPlayerData. First, we'll check if the file exists. Use the binary reader if it does. Call a debug log if it doesn't. And set the player's data to the default values. Use the binary reader to read the data written in the save.player.data file. And set the player stats to the values saved. We must, of course, load the scene first. In the bench script, we'll call savePlayerData after we save the bench data. Then we'll call the loadPlayerData in void start of the player controller. For testing purposes, I'll also call the savePlayerData if I press P. Now if we play, I'll move to another location and save the data. And stop playing. Awesome, it works. Let's test it out for another scene. Epic! Now as you've probably noticed, once we change scenes or exit the play mode, the shade despawns and we can't get the full mana back. So let's create a save system to save the shade's data as well. So firstly, like the others, we'll need some variables. We'll create a vector2 shadepos, string scene with shade, and quaternion shade rot. Then we'll create a function, save shade data, and write in a save.shade.data file. We'll set the variables with the current scene name and values of the shade instance. Then we'll create a loadShadeData function. We'll load the values from the save.shade.data file if it exists. Otherwise, we'll call a debug log. Now we'll call this saveShadeData function in the shade's-awake function and when the player leaves the scene. So in the scene transition script, we'll check if the shade exists in the scene before we call the saveShadeData, otherwise we'll get null reference exception errors. Then in the game manager, we'll call loadShadeData in awake if the player has half mana, as that means they have died and haven't killed the shade yet. Then we'll check the current scene name if it's the same as the scene with shade, and instantiate it if it is. Oh, I'll also call the save player data after they kill the shade. Alright, let's test it out. If the shade spawns in and I leave the game and I go back in, perfect, the shade is there. And if I move it to a different scene and go back, awesome. Alright, so now we have a death and response system, shade enemy to restore full mana, updating map, and a save system. Before we end off, let's clean up the project files. Shift all the scripts we have made today to the scripts folder. And that's all I have for you in this episode. In the next episode, we'll be covering pickups, unlocking abilities, and an inventory system. Thank you for watching till the end, and I hope you've enjoyed the video. Want to support what we do? You can help us by becoming a Patreon. This will give you access to the project files for our tutorials, as well as Patreon exclusive posts on our blog. Any support you can give will be invaluable to us, as currently we're only making back about 20 cents for every dollar we put into content creation. So your patronage will go a long way to help us make this a sustainable endeavor. See you in the next video.